So int my array new int 8. So this of course initializes an array with the size of 8, and this is called a one-dimensional array. An array whose elements are arrays, that is, an array of arrays is two-dimensional. It's like a table that has a row, number, and a column header. So I hope I have Excel here. Yes, okay. I'll pull this up and then we can look at what this means. Oh, I did launch it. Okay, it's very slow. Oh, sorry. Okay, there we go. Whoa. Okay, so kind of like a row and a column, right? So here we see in Excel, we have like a row and a column. And when you kind of look at an array or a two-dimensional array or multi-dimensional array, or especially a two-dimensional array, we can look at it like this. So we have a row, right? And then we have a column. So when you kind of store arrays or two-dimensional arrays, this is how you would initialize it. So we can just talk about it like this. So you have, so this will kind of initialize our one-dimensional array. So one-dimensional new int and with, some values or whatever, right? And when you're declaring or initializing a multi-dimensional array, you have to go, this will describe a one-dimensional array, and then the more brackets you add after that will kind of tell it the dimension, or kind of like how many arrays are in each kind of array. So what I mean by this, I'll explain. So this will be a two-dimensional. It's going to new int, and then you have to do something like this. So this will kind of initialize our two-dimensional array, but we have to give it, we have to give it a size. So the initial size we have to give it is the size of the outer array. So this means is that when you're storing kind of numbers, when you're storing numbers, right, or one-dimensional array, something like this. So you give it the size of something like this, right? So in this case, and for this example here, it's going to be 2 and 3. So when you're doing a two-dimensional array, it kind of looks like this. You have an array, and then you have an array inside of this. Right, and this can store 2, 3, 23, 54, depending on the type that you give it, right? So in this case, we're going to talk about ints. So 2 and 3. Right, so we see in this case our array, our outer array, so it's going to be basically, kind of our array that stores our arrays, is going to be a size of 2 in this example. And you can give it whatever size you want. Of course, it can be like 100, 200, whatever you need. And the other, number in the other square brackets will tell it the size of the inner array. So this array. Where so in this case, we have an array which has, maybe like 2 rows and 3 columns. So in this case, it would look something like, the first row will have kind of like you'll point to an array, or if I could like type in here. Apparently I cannot. Okay, so I'll let that be. So do you have a real example for using two-dimensional array? Yeah, so we can do something like a grid system. So like I think on Friday, I talked about kind of creating kind of multiplication table or something like that. So what we can do is probably the same thing. So to store this, we can do something like this. 2, 3, 1, 2, 3, 4, 5. I mean, think of it like a board game, right? 7, 8, 9, 10. And then later, you have to go something like 11, 12, 13. So instead of doing something like this, I'm actually going to give it some sort of value. So I know in a board game, so let's pull out like snakes and ladders. Right, it's a bit weird. So if we look at this picture here, so let me annotate here. So we have, in this case, we're going to have, I think it's of size 10 or 9 or whatever. Maybe choose a different color here. Yeah, this looks like a good color. So I can't do it straight, apparently. So I'll do it as best as I can here. Right, so our array is going to basically, our two-dimensional array is going to be something like this. So the first index is going to store all of these numbers. The second index, our second array within our main array is going to store all of these numbers. Our third array is going to store all of these numbers, and so on, right? So this is kind of an example of the two-dimensional array and how you would kind of print this out. So what we can actually take a look at is how would we actually do this? So we know that we want to store, numbers in this order. So 1 through 10, and then 20, 11, 21, 30. So how can we go about this really? So we can actually look at double for loops. So we know that this size is going to be 9, and I think this size is also going to be 9. But we can take a look, and we'll run through the debugger to see how this works, and if I'm doing this right. So for I, so we know that our size is going to be our two-dimensional array at our first index of dot length, right? So this two-dimensional array dot length is actually going to point to the actual size. So of the other array. So it's going to be, the size of this. So in this case, it's going to be 4, but we set it to 10, so it's going to be 10. Right, for I, so we do something like this. And then we can do two-dimensional array at I, dot length. So this will actually point to the length of each of these arrays, right? So whatever size they are, so we said 10, so it's going to be storing like 10 numbers, right? So something like this. So this is storing 10 numbers, so it's going to be the size of this. So we give it a value of 10, so it's going to be the length of 10. So each of these will have 10 values. So because the way the Java initialization works, it's actually going, give it zeros initially. And then we're going to update what it is and print it out. Okay, so let's say we want to recreate this. So how do we go about this, right? We want to go from 1 to 10, and then 11 through 20, or maybe 20 through 11, something like that, right? So because we're starting from 0, maybe that's not the best case, but we can work with this, right? So because we're starting from 0, we want to store the first 10 numbers into the first like array of arrays, right? So the way to kind of look at this is, we have a bunch of arrays, and we want to store, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in here. And then here is going to be kind of look at it the same way. It's going to be 20, 19, 18, 17, something like this. So this is how we want to go about this. Right? And kind of the way it's going to look like when we print it out is going to be something like this. And right, when we print it out, I guess you guys will see. So they're going to be exactly like the same way as this board is going to be. Okay, so the first thing we want to do is probably figure out how we're going to store 1 through 10. And to do that, what we can probably do is, well, the first thing we can really do is work with this j and I value, because these are like the incrementals that we have. So starting out with I here, it's actually going to be point to our, our first initial array. So when we have this array of arrays, right, it's going to point to basically this position. So that's what we're going to access. And so it's going to be int, or sorry, not two-dimensional. I spelled dimensional wrong, but don't worry about that. So it's going to be two-dimensional at I. So it's going to point to this array. So now we're accessing this. And we want to access, now we want to access the first index within this array. So to do that, we give it an underscore bracket and we tell it j, right? And then we have to give it a value. So what we're actually accessing here is, let's annotate here. So, we're accessing this array, and within this array, because we initialized it to like this, so we know all of the values are going to be 0 inside. Within this array, we're going to access the first index, and then later we're going to access the second index, and so on and so forth. Right, so let's clear all this out. Okay, so we can't just put in a hard-coded value here, like 1, because that will mean that this entire board here is just going to be full of 1s, right? We don't want to really do that. It's not going to make sense. We want to store it like this. So the way we can do this is like, okay, we can take a look at I, right? So I, what's I going to do is every time we increment I, it's going to be, the value of I. But, on last class, on Friday, or the previous class, for last class, on Friday, I kind of explored two-dimensional or like nested for loops, right? And with nested for loops, the way it works is, it kind of loops. Oh, sorry, here. So it's going to loop this loop, it's going to finish it, and then it's going to go back up to this loop, right? It's going to check, it's going to increment, it's going to check this conditional, and if it's, if it's still valid, it's going to go back here and loop this again. Right, so we talked about this. If it doesn't make sense, please let me know, but we're going to go through this again. Right, so setting here this I value, what it's basically going to do at this point is at the very first array, instead of it being 1 through 10, what it's actually going to do is, because our I value is 0, it's just going to be a bunch of zeros here, instead of like the actual value is supposed to be. So what can we do to kind of combat this, right? So we can do something like j, for example, plus 1. Why am I doing j plus 1? Because we start from 0. And because we start from 0, j is going to be 0, or it's going to access our two-dimensional array at, that point, our first array within our array. And then it's going to be 0. If we set it to j, it's going to be, if I go here, it's going to be 0. Oops, it's going to be 0, and then it's going to be 1, and then it's going to be 2, and then it's going to be 3. But we actually want it to be 1, 2, 3, 4, 5, 6, up to 10, right? So if we increment j by 1 here, or we add 1 to j, or not really 1 to j, but, have this expression here that will evaluate j plus 1 to this position, our first row is basically going to be good to go. Because, oops, sorry. I know I'm jumping a lot, but if it's annoying, tell me. So at this point, we kind of have the first row ready to go. So we have 1. So we basically have this complete. Now we need to think about doing the second row. So we can kind of go and take a look at what is going on with our two-dimensional array. I think that will make more sense. So if I put a debug here, and I think if I comment out this. Okay. You fill out 1 through 100. Well, let's take a look. It's gonna fill out. Not necessarily. No, it's not gonna fill out 1 through 100. And we'll take a look at why and why that happens. Oh, sorry, I pressed the wrong thing here, like I usually do. Right. So here we can take a look at our two-dimensional array. So this is at position I. So our first index here. So I think if I move my head here. Okay, so here we see our two-dimensional array and all its values, right? So we see it's an array within an array, and each of these have initialized values of 0. All right, so that makes sense. Kind of went over that. So in here, we kind of see two-dimensional I. We see which array we're actually accessing. So, and then we see all its values. All right, so we didn't do anything yet. So all the values are initialized to 0. So when we kind of loop through this, it's 1, and we can kind of see this as well. So we see that this is 1. And then if we keep going, I'll do it a few times. Right. So we see that we kind of went through this for loop here, and we initialized all the values to what they're supposed to be in the first row of our snakes and ladders, right? So 1 through 10. So this is what it's supposed to be. So at this point here, our j value is actually going to be equal to 9, right? Because we can look at it here. Our j is equal to 9, our I is equal to 0, right? So because j is equal to 9, it's going to increment to 10, and it's going to look at this, statement, or not statement, conditional statement. It's going to be 10 is less than 10. Well, that's false, right? And then it's going to exit this loop, right? So that's what's going to happen. It's going to go back up to here because there's nothing else to run after, right? And what it's going to do, it's going to increment our I value by 1, and then it's going to go in here again. So, right, so we see it incremented our I value, so now it's equal to 1. So now we're accessing another point in our two-dimensional array. We're accessing this array here. So we finished up with this, and now we're doing this. And when I go through this, j gets reinitialized to 0, and then it's gonna run the exact same loop again, right? So we can kind of see that, these values are going to be exactly the same. And if I loop this a few times, right? 6, 7, 8, 9. So we see I looped it, the same amount of times, and the values are the same. So doing j plus 1 doesn't fill it out to 1 through 100. It fills out the array, but not in how we want to. We can see that it doesn't really, match our snakes and ladders table here. What we can do instead, we have to do probably some mathematical operation to actually get this in the way we want to. So we know we want our first row to be 1 through 10, but then we want our second row, our second row here to be 10 to 11. So we kind of wanted to go the other way, right? So how would we go about this? Okay, so I'm gonna stop running. We all see why it's not going to work, right? Because we go back in this for loop as many times, 10 times or 9 times or whatever, and every time j gets initialized to 0, which kind of doesn't make any sense. What we can do is probably we can do something like this. We can have like an int, cell is equal to 1, and then we can use cell here, and we can probably increment cell plus plus or something like that. We do something like this, and this will actually run all of our dimensional array until like it's filled up to 100. So how does this work? Let's rerun our debugger here. Let's stop here actually. Yeah. So say we have an initialized array of 0 again, you know, all the values are 0. Kind of start looping through this. We see that it fills it up with 1 and 2, and I'm gonna go until I hit this again. So see it's filled up 1 through 10, and then cell is actually 11. So, you know, this kind of works. But the issue with this is that when we go in and give it a value, it's actually going to be 1 through 10 and then 11. The value that we actually want is for it to be 20. So, you know, maybe this doesn't make too much sense to do this. But, you know, maybe we're getting somewhere, right? And if I was to run this until completion, I think, you know, I'll just run it a few times. You know, we kind of see it fills it up like this, right? So if you go here, we have our array of arrays. So we have 1, 2, 3, 4, etc. And then we have 11, 12, 13, etc. Yeah, they only go in ascending order, right? So, and it's going to be 21, 22, 23, etc. Right, the game goes ascending to descending, exactly. So what can we do to really go about this? There's a few things we can do. I'm just going to stop running this for now. Well, we know that the first row kind of does it okay, but then it's supposed to start at 20. So what can we do here to actually, you know, make it right? So if we start at 1, it kind of, you know, it makes sense for the first row, but then later it doesn't really make any sense. We can actually do an operation here to maybe make a little bit more sense. And maybe remove this to see. So we start at 0 for I, so it's going to be, our cell is going to be 0. Okay, let's say our cell is 1. So our first initial kind of like input is going to be 1, 2, 3, 4, 5, etc. 5, right, etc. And then our next needs to be 11, 12, etc. Right? Or sorry, 20, 19, 18, etc. And then it needs to be 30, right? 29, etc. So it works for kind of like the first one, right? So it does this, okay. And then we need to do something here instead. What can we do? We can do a lot of things, but I guess thinking about this a little bit, what we can do is probably do an operation here that will either what we can do is actually go backwards, right? Thinking about this, it might be a little bit easier. So we can start at 10 here, right? And then we can start at the first position, and then here we can start at the last position and go backwards. So this may be a little bit confusing, so I'll run our debugger here and show you guys what's actually happening. Right, so it's at this point, our two-dimensional array looks like this. Let me just go up a little bit, looks like this. So when we start filling in values, we see it's actually being filled from the other way. Instead of going forwards, we're actually going backwards. Right, so, you know, is this the right way? Well, first of all, we want to decrease this. So let me just rerun this. Because if I don't decrease it, the next value is going to be 11, which is not what I want. So let's rerun this again. Okay. So if I keep going here, go a few times, we see that it does it, the right way, kind of fills up the numbers the right way. But if you keep going, well, it looks like I need to set it to, first of all, it's out of bounds. Let's take a look why. Just going to error out. So something we can debug here. So take a look at the J value here. So it's going to fill it up. 7, 6, 5, 4, 3, 2, 1, 0, and -1. So that means that, my condition here is actually wrong. What we want it to be is, well, if we change it like this, J, the length is 10, and J is going to be 9. So it's never going to go in here. So the initial loop is going to be 9 is greater than 10. Is that true? Well, it's going to be false, and it's not going to go in here. What we actually want to do is probably, check if J is less than -1 or less than 0. Right? And if we rerun this now, we actually should, kind of fix this issue. So if we run it, oh, well, first of all, is J less than 0? That's false. While J may be something like J is greater than 0. That's what we want. Because we want 9 to be greater than 0, right? So now we can see it actually going inside. You can see that it's filling the values up okay. So let's keep going here. We get to, oh, well, we actually didn't get to it. So when is 0 greater than 0, that's, this is false. So we have to do greater than or equal to 0. Or just, greater than -1. But I'm going to do greater or equal to. If we run it again, it should be good. Now, for however many years I've been doing this, it's I still make mistakes. So it's okay if you guys make mistakes, of course. So see J is 0, it went in. So now we have all of these values. Right? So what we can do at this point, so now we have cell is equal to 1. And what we can actually do is because it's equal to 1, we can probably do something like cell is equal to cell times 10 or something like that. But doing this, it won't work because at one point, cell is actually going to be 11 or 20, right? And that doesn't make any sense because at this point, cell is going to be 1. And if we multiply by 10, that doesn't, it's equal to 10. So that doesn't make sense. What we want to actually do is maybe add 10, right? So this will actually be 11. And again, we're going to start at this position here again, right? So if we add 10 instead, I can do this, right? add 10, and then we rerun this. I'm gonna run it once here. So we have this, but it looks like our sub value is actually equal to 10. So we need to add 11 to this. So if I run it once, it does this, it fills it up. And then if I go in again, so our cell value is 11. And then we start filling it up, it's going to be 11. So that's actually what we want. But it's going to go down. It's going to be 11 and then 10. So kind of maybe not what we want here. I'm not going to keep going with this because there's other things I want to cover. But try to see if you can figure it out. I will post the actual, the answers to this on how to actually create that grid in the code that I'm going to send you guys after the class. So I would suggest, it's a good exercise to do. So try to figure it out. I think we're gonna sit here for another 30 minutes trying to figure it out. So I'm not gonna sit here because there's other things I want to go over. But the main concept that I want you guys to understand is the two-dimensional arrays and how we access them and how we set values to them, right? So I think going through this example and then trying to recreate this two-dimensional this ladder, kind of like gets the point across. So maybe a rule is to sort in descending and ascending according to rows being odds or even. So you mean like do this one and then do this one and then do this one and then depending on this do this and then this, or do some sort of like if statements. Odd rows go ascending and even rows go descending. Yeah, you can do something like that. That's a good good look at it. There's many different solutions, so whatever you come up with, it's probably like, it's okay. There's no one answer to a single problem. It's complex and time consuming, yeah. So I'm not gonna go over like complex and time. I think one day we're gonna have a free class and I will go over it then because it's a good thing to know. Right, so this kind of like explains two-dimensional arrays with this example. So I guess you kind of maybe understood this a little bit. So there's kind of a dilemma here. So when we create an array using like new int 2 and 5, do we have a table of 2 rows and 5 columns, or is it 2 columns and 5 rows? In other words, are we first specifying the width and then the height, or are we specifying the height and then the width, right? So first the height and then the width. Well, as we often say, everything is not so simple here. So let's start with the question, how is an array stored in memory? So of course, computer memory doesn't actually have a matrix in it. Each location in memory has a sequential numeric address. So 0, 1, 2, in our case, we speak of a 2x5 matrix, but in memory, it is just 10 consecutive cells, nothing more, nothing indicates where the rows and columns are. So what this means is, I think going back here, what it actually says is that, this points to a memory. So, when we initialize kind of like how arrays work, we said that we store the memory and then in the memory, we actually look at the location. So what happens here is that this memory is actually stored, a list of memories, right? So it's going to be whatever the value is, and then that points to the actual like the values of the array. So this is kind of how it works. In a similar way, instead of like, it directly pointing to this in a one-dimensional array, it's actually going to point to another location in the multi-dimensional array, and then that location is going to point to, perhaps the value or maybe another location, depending on how much you're kind of like nesting your arrays. And when when kind of fast initialize, so fast initializing is what we said we do here. With this, you can also fast initialize kind of our multidimensional array. So we can do something like int board is equal to new int, and then we can do 1 to 5, and then oops, 6, 7, 8, 9, 10, for example. And to print this out, you would have to do a nested for loop. So first you have to do board.length, and if you try to do, where's my mouse? Okay, if you try to do this, if you try to print that, like we said, it's going to be board at I. Sorry, 1 second. Sorry about that. My dog started eating toilet paper. Right. So when we start doing this, this will actually point to the location in memory. So if I do something like this and I run this, right, we see it's actually a location in memory, right? Like how I said before. Well, I can bring it back now, but how I said before, how we kind of store arrays. When you store a one-dimensional array and you're trying to print it out, it's going to point you to the location. So basically here, you're basically pointing to another location in a multi-dimensional array. So to actually print the value inside of this array, we have to nest our for loops. And we have to do board.at_i.length. And then here we can actually print board I j. And this will print us the values. So if I run this, now we can kind of see that it works here. So I can do maybe like do a separation here. Something like this, and I run it. Okay, so we can see there's like a separation here. Okay.